Okay, looks like we're recording. Today we have Alex Zharichenko. He's a close friend and colleague with degrees in statistics and computer science from the University of Pittsburgh, and he's worked at Uber's ATG, which is now spin off to a new company, and he's going to be talking to us about getting jobs in industry as compared to academia. So if you don't mind, Alex, take it away, and thank you for coming sincerely, especially on the short notice.
Absolutely. So this talk, kind of just the general overscope, I'm going to be talking about landing a position in the data analytics space, which kind of encompasses this data science, data engineering, machine, all these kinds of things. But I'll just reiterate, who am I? I'm Alex. I live in this place called Pittsburgh. It's kind of cold here sometimes, kind of warm. Why am I here in this place? Because I went to this university that happens to have the same name as the city. I got these 2 degrees that look exactly the same, but there is a minor difference between them. One of them happens to be computer science, the other one happens to be statistics. Um, Other fun thing about this area is there's like this very, I don't know, unknown university next door, called Carnegie Mellon. Totally, I don't, totally does not have an effect on like job opportunities around the area. No, totally not why most major tech companies are just like here, there, everywhere. And I just happen to work at one of the fun little self-driving ones. There's a lot more than just like the major ones like Apple, Microsoft, blah, blah, blah. What do I do? Technically, by my actual title, I'm a software engineer, which is, but like, that's not what I'm advertising. I'm advertising about how do I get into the data science, data engineering space. Well, I work on data mining. So probably some context. I at Aurora, which is a self-driving company, we're working on self-driving trucks and self-driving taxis, which will eventually be on the Uber app at some point in time. That's what happened when Aurora acquired the previous little Uber's little technology group that does self-driving that I was part of. I work on the data analytics and engineering team, and my whole thing is just to do data mining. So that's why the reality of what I do is I'm more of a data engineer and data scientist. And I think to kind of put this in perspective, because this is super, super confusing and there's no like well-defined thing that describes these kinds of things. There's this great spectrum. It's not the most perfect spectrum. I think there should be another role at the end that just says researcher. But this is the sort of spectrum where it goes from software engineer to data scientist. And as you go across the spectrum, you go from solving problems to more exploring data and solving problems in a kind of different way. My title says I'm this. What I do is almost the entire spectrum. To put this in another way, there's another great diagram that's just like the hierarchy of needs for data science. And at the bottom is like collecting data. And this is what a software engineer does, is just like implement these systems, blah, blah, blah. And then above that is like, okay, trying to get the data there, structure it, infrastructure, cleaning it, labeling it, data mining it, all these things. That's now the data engineer. Then data scientist is more like analytics, metrics, A/B testing, and all this stuff. And then the very top is still a little data science, but then that's like researcher kind of stuff. So I am these levels. That's what I do. And this just like help put in perspective of what the roles might be in these different levels. That's why this is a very confusing field, because I can say most of everything at the top of this is data scientist, and I wouldn't be entirely incorrect. And so to sort of structure this a little bit better, what skills are it's sort of like what skills are needed, because the skill need changes from one side of the spectrum to another. But there's like 2 core skill sets. Very simply, you have engineering and you have analytics, statistics, and math. And as you slide, what you need from each of them changes. But you still kind of need a little bit of both. So a good example was today. I had a meeting between me and my team and data scientists. We were talking about weather data because it's really awful data to get accurately. And so like the data scientists had to understand what we were worrying about on our engineering side, and we had to worry about what they needed analytics wise to actually do their things about thinking about trucks driving in different weather. So it's kind of is always, you need a little bit of both. As like, even at being a data scientist, you still need to understand some fundamental things about like, how do those engineers get the data? What is like reasonable things, all these kinds of sorts of things. So I think a little fun thing just to, if you actually try to get the breadth of it, is what can you do with this kind of stuff? Answers a lot of things. So I, in fact, happen to have the breadth of knowledge. And it lets me do things like, first internship, I did a little NLP for a cyber intelligence study, which was kind of really cool. And then also I have ideas like, I want to make a good cocktail recipe, but I don't have all the ingredients. Can I just machine learn my way into just giving all the ingredients and it just makes me a recipe? Or maybe I can teach an RL agent to learn the Kelly criterion, or maybe visualize the semester as a progress bar to kind of freak me out as how fast, like, a college semester can go by. And just, there's a lot of different things that this skill set provides in general, which is kind of why I like always encourage, like, if you don't just be stuck in like the math, learn a lot of the engineering, because there's a lot of really neat ideas you can just solve on your kind of own. Like, I'm trying to right now grab all my data from like my watch to my bed to combine it into this convenient like fitness dashboard. But how do I get here? Or maybe what gets me, probably more importantly, the job. So just a little bit about sort of like thinking maybe academia versus industry. Why would somebody ever want to go into industry? I mean, money. People, PhDs don't pay that much. Some research positions here and there don't pay that much. Money's definitely a good reason. Time. I mean, I get to start my days at like 10:30 a.m. if I feel like. I have a lot of flexibility with my time. I have flexibility of time afterwards. I get like, healthcare and all that kind of stuff. But also there's some rooms to be maybe more innovative, especially if you go to like a startup. You have a lot of problems here and there, and you can just sort of tackle anything. It's kind of still can be an open space for you to think about things. Or in the sense of being a data scientist, you kind of need to think very broadly. Also, sometimes there's just a little more freedom, maybe more restriction. That maybe just depends on which corporation you're in. Learning, I think that's still a constant. If you're ever in engineering or data, like, you have to still keep up with the new things all the time. Programming languages will change. Libraries that you need to use to do your tasks will always change. It's a constant moving cycle. And then also job security is pretty good. Most organizations will never take out their analytics departments because they are just so critical and vital to knowing how things are going that you pretty much have pretty good job security. So how do you get in? Or maybe what matters most to industry? So let's like take a step back and kind of set a goal. So I want to get into industry, or maybe more specifically, I want to land a job in a data and analytics position. So we got the goal. So we need to find a job and we want to be the most desirable candidate. That seems like a good two things to kind of tackle. And so tackling on the one side is your technical skills. And these are your skills of the, engineering variety. Like, can you open up Python? Can you do statistical analysis? But the question is, how do you prove this to an organization? That's a really interesting thing. Perhaps a resume is a great way of summarizing that. But it's what a recruiter sees. And so how do you convey that you have the skills necessary? One way is, you're all at a university, you're getting a degree. That's a way of showing it. What can this tell us or a recruiter? Well, we have a bunch of things like school location, GPA, area study, what you are. This all can convey different things. Frankly, we can't really optimize school and location. You're kind of stuck in one, but you can change your GPA. You can change your area study. You'll eventually get to control what year you are in. But these are kind of GPA is kind of the only greatest thing that they have to know, because it's like you come in and you say you're maybe math or your statistics, or computer science, and then you look at your GPA. And if a recruiter at a tech company sees a 4.0 GPA, they're going to be like, maybe. Like, it actually doesn't tell them much about you besides you're really good at school. And this is for, at least for major tech companies, a good academic standing is a good thing, but like you can probably have like a 3.0 and be okay. There's one thing that definitely is missing from here that if you probably have not considered putting your resume, do relevant coursework. If you don't think about putting the classes that you've taken on your, or like the most relevant classes on your resume, probably do so. Because so if I was going to a data science job, I probably want to mention that I've taken classes in probably statistics, maybe a statistical learning class, maybe a data science class. Maybe if I'm doing engineering, I want to show I've done algorithms and data structures, very fundamental classes that, like, when they see it on the resume, they'll just circle it, be like, yep, boom, they now pass like the minimum bar. But yeah, and so again, it's kind of hard because, like, how much can you infer from a 4.0 student? They probably did good. Maybe, you know, they had some team projects, someone else was pulling the weight. Like, you don't really know too much. And like, what about a 3.0 student? They could be also a really talented data scientist or like data engineer, but it's kind of hard to tell. So a degree kind of sets a baseline. Like, that's the convenience of going to college, is you have the baseline requirement. For some organizations, that's the maximum bar you need to pass. You just have to look pretty and they'll give you a job. But for larger companies, this is kind of still a risky gamble because you don't really know that much. So what are other candidates doing? What kind of brings you up? Job experience. Wow, crazy. And like, one of the most nicest job experiences is internships, but I think internships then leads back to, it's the same problem of you want to land the position and you need skills to get it. It's a fun cycle. There's an alternative route. So the other great way of displaying the skills is through university jobs. For me, I was a undergraduate teaching assistant. That's what UTA stands for. I don't know if that's a common thing, or you can be a peer tutor or get into research at your university. These are the most very effective ways, because they can look at you being maybe like a 3.0, 2.6 GPA student, but you did research or you were a peer tutor, and that automatically elevates you above a person with a 4.0 with no experience. Because at least in that situation, you know, you have validation, great validation in your GPA, because you can teach somebody, which means you probably know it. Also, because research is a good validation of your skills. It's a good, you know, I think I'm maybe being a dead horse, but, you know, you're applying your skills into something real. Note that be careful of some job positions. Like, you know, there's probably positions at the university of like being a web developer. That's fine. Some organizations may take that nicely. This might put you in a trap. So I come from the computer science perspective mostly. And when your resume is full of like doing web development, they typically shove you into a web development position. And our goal is not that. So it can be useful to just show that you're competent, but that's about it. Just a little interesting knowledge. They read your resume and they figure out, this person can do this. I'm going to put them where it says, just like how it's like, I've done data engineering. I guess I should be on the data engineering team. You know, recruiters are not like the hardest thinkers in the world. So what are other candidates doing? Okay, so this is like some evidence. What's the other way? Personal projects. You see those billions of ideas I have? A bunch of them I have half executed. They're fun. They're fun to do. And they're actually another great display of your skills. Though, because like taking kind of a cool idea, like a different way of thinking about something, like maybe I'm just building a sports gambling simulator just to test, like, will I get a positive expected value on a strategy? You know, that's a really effective use of skills. A lot of statistical like inferences I have to make to like get to that conclusion. Really great, especially if you can make it public. But they're extremely hard to do and hard to execute, especially if you have grand ideas. That's why the tip is always to make them small and targeted. Also, just know that like no project is incomplete. It's always just a thing in progress, because most of mine are just in progress. And don't ever be afraid to just like, if you get what you need from the project, just dump it. It's okay. An alternative to that, there are datathons and hackathons. These are really great events for kind of getting experimental and having and try to like actually throw you into the skills. So I've done a datathon before. Usually Texas A&M does one every year, and I think, I don't know if you have to be there in person or you can do it virtually now, but the very convenient thing about them is that it kind of, in a 48-hour, 24, 36-hour period, it throws you into a problem, makes you force you to work with random people or people you know and try to like bang your head out to solve it. And so in the case of the datathons, which are probably more convenient, the problem, you're trying to solve a problem with data. And so you have to, you can start throwing yourself at this data, try to think about how to apply now all these things like clustering, regression, all these things to that problem, while also maybe just saying like, I don't know Python, I guess this is my time to learn. Like there are really great excuse for that. Also for communication and planning skills. I'll come back to that at a later point of that. That's a very useful skill set that you'll need later. And hackathons can provide some good experience. But basic summary, degrees are a good baseline, but experience is what really makes you shine. So we can sort of like label as a metric of like, we want to elevate, we want to sort of maximize the evidence that we have experience or our skills in action. And don't forget this experience. This is the one thing that this is kind of the key. Industry does care about experience more than GPA. Some companies are like GPA minimum of 3.0. Other companies are like, honestly, if you're doing a lot of things outside of school and you have like a 2.6 GPA, come on in, buddy. Like you clearly, you're optimizing correctly. And so that's one portion, is just like, let's get your skills up. The other portion is of landing these positions is the interview process, getting and passing an interview. And just sort of just go on and just very briefly, like, obviously you need to apply and find them. And this is a tricky game, especially for entry and internship level positions. It is kind of a numbers game of you have to apply to 1,000, maybe get one interview, probably get like 80, 90 rejections. It's a very crippling process, but you do get very hardened by it. And then you do feel very rewarded when you do, when you do succeed. A kind of tangent of that, know people. I mean, not really know people, but interact with people. Because the problem is it is a numbers game unless you know people who can just refer you. Not all referrals work, but they're very more likely just to throw you into an interview faster. This is the advantages of just knowing people within your class or the classes above you. Because even if it's like somebody maybe in your class who's a super, one of the top students in the class gets the internship, they can probably likely refer you the next year around. Or if they go off to this one job, they can refer you then. So like for example, I work at Aurora, but someday maybe I want to work at Coinbase, and I know a person who I can immediately just ask for a referral, and within like 10 seconds, I'll have a referral and I'll have an interview set up. That's kind of the benefit of knowing it and realizing he's like an acquaintance. So it doesn't need to be anything like great, but just this is the benefit of just networking with people. And I put networking, I'm gonna put networking in quotes because it's just like, just be a normal human being. And just like, you don't need to be like super good friends, but like most people are just like, oh yeah, sure. If you ask for a referral. But that's like the easiest way to get fast tracked into that whole system. Next part is the interview, which has usually in this situation 2 components: behavioral and technical. So behavioral, this is like most interviews have this component. It's not a crazy component at all. It's all soft skills. This is where you go to a hackathon. Great. This is the greatest time to like put your soft skills to the max, because it is time management, decision making, your motivation and communication, and sort of putting yourself in situations of like research, hackathons, or just normally working on a project. Having those experiences and then being able to talk about them is what makes you get past the section very, very effectively. It's kind of like you should go out for those kind of experiences. And then the other one is the technical questions. And sometimes you might get thrown into a coding interview. which is more a time about exposing your thought process. And I will go into a little bit later what that means. But then besides that, it will be mostly just technical questions, checking your knowledge. And I think one example was I did an interview to be a machine learning engineer at one company. And one of the questions was, we have this deep learning model and we have this data set. How can we, just by modifying the data set, make a more robust and accurate model? And this just means just getting a knowledge check on like, oh, if we start to modify the images in the data set and, flip them and all these things, we can actually now have a larger data set, and it can do a better job because now it's not just like focusing on certain details. It has to actually do a better job. So it is like, this is where you're taking all those things you're kind of learning along the way, either through classes or through just plain experience, that now is like, this is now getting finally tested. Most of the times it doesn't end up being as what I just said, that kind of example, but they do involve sometimes some thought that really does prove that you do know something. And so, okay, the metrics of this side, you want to kind of prepare for interviews, and you can actually prepare for these because you can, look up what are behavioral questions and prepare what kind of would you say, and that actually can help you when you go in the interview say more effectively what you want to communicate. And then also just interact with others. I don't think this is, I don't know how much of this problem in other majors. I know in computer science, sometimes people are a little closed off. And so sometimes being social and interacting with each other is it's a very good thing. So to kind of structure this even more, we have these two metrics. We want to kind of, let's structure this a little more. There we go. We have these metrics to maximize. We want to maximize the kind of the evidence of experience through actually doing things. We kind of want to have some preparation for interviews because sometimes interviews are completely just random. And so sometimes just being good at them can get you by more than you'd think. And then just interacting with others in more kind of teamwork, collaboration, and networking scenarios. I want to be kind of specific on that. And there's a lot of ways to do it, and this is just kind of rehashing them. Get university position, get through your degree, learn from your classes, side projects, clean up your resume, work on coding challenges, do mock interviews with your friends, go to hackathons. This is like the kind of standard information. This is just kind of me saying like, what won't, like, just being a good student, I think can get you fine by like doing what you've been doing since since whatever primary school. That's fine. But if you really want to like get into these cool positions at like big companies, it's not sufficient. You need to do a lot of extra work. And so time for some just tangents. And this is just sort of kind of like other things to help kind of build up perspective on like, what would you probably need to do to kind of land these positions? So what knowledge would you need? Looking on kind of both the engineering and math side, I'm going to show you some things. It's not like the complete things, but I think as a good base on both sides, you want, on engineering, know a programming language, maybe R, maybe Python. I don't know about MATLAB. I don't think anyone really uses that in industry. Know some algorithms, know some data structures, because algorithms, data structures are your fundamental toolbox. How you represent data is one whole problem in itself, and how you can run through that data effectively is another problem. And then know your basics like probability, statistics, calculus, linear algebra. And then from there, it starts to build up. So on the engineering side, now that you kind of have these fundamentals, you kind of want to, for at least the data side, know what databases are, how to store data, maybe what SQL is, how to manipulate the data, because that's a whole other thing of like, you might have all this raw data, but it's probably not useful until you do something with it. Like if you have a column that just says male and female, you probably need to turn this into 2 columns and create a dummy variable or something like that. There's some additional manipulation you need to do. Maybe data scraping. Maybe you need to learn how to build your own data set, because maybe what you want to achieve does not exist. And so you need to learn how to do it, how to build a good data set, and then learning how to kind of make a dashboard to just show the data. And then on the math physics side, learn then linear regression of the most fundamental kind of model, but still very useful and powerful. How do you do model selection on it? How do you do data reporting and data visuals? Like, how do you report statistics? Because it is a communication problem. Because it's not like you just provide like, oh yeah, this result was significant. It's significant with context. Like, it's like, oh yeah, the students did better, but it's only this segment of students did better in this class than in the other class. You have to be it's kind of how do you convey the specifics, but not get like drowned out into it's a whole like mess to communicate statistics, essentially what I'm saying. And that's why it's kind of important to like know how to report it nicely. And then sort of just getting, when I say data perspective, I mean like you look at the data and you can think about things with the data set, like how many samples do we have? How clean is the data? Is there a lot of empty like empty cells in there? What do the distributions of each of the columns look like? Kind of start to think about like what's going on in all those kinds of things. And then to layer on top is now the more kind of big things, start taking the higher statistical classes, thinking about like time series and Bayesian statistics and other statistical learning models. This can now go into things like deep learning and whatnot. Get the full toolbox of like what can you do and what kind of analyses you can do, because time series data is different from regular data because most statistics doesn't work on time series data, so it has its own set of things you can do. On the engineering side, this is where you think about high performance computing, because for example, like I deal with the scale of data I deal with terabytes of data, and so like one computer cannot process terabytes of data. You need a whole system to do that. And how do you go through such large files effectively is a whole like engineering problem in its own. And then also learning how to train and deploy these things. Like for my job, I really think about these things where data comes in. I want to know how I can label this data. I want to know how I can set up a validation system to validate that what we're predicting as events, like especially I'll give the example of weather, because sometimes they provide like, hey, it's foggy, and it's not foggy. And so I have to now figure out how maybe I can use their raw data for humidity and dew point and wind speed to then figure out if it's foggy or not, and see if that's a better predictor, and then need to validate that and have to validate that on a consistent cycle. It's a whole lot of like system engineering, thinking about how to like keep something accurate over time. And then just to layer on top, just training machine learning, or like, yeah, there's deep learning, AI, there's a lot of other stuff, but I think like this is like some basic fundamentals are like, can you work with data on a computer? Do you know how to do some statistical things? Very basic ones. Most companies don't need deep learning. They just need like a linear regression model, and they'll be super happy with it. And so next tangent, tech internships and coding interviews. Tech internships are kind of highly competitive. There are some job postings that get tens of thousands of posting, or tens of thousands of applicants. So they do a lot of filtering of most of them. So don't let small places deter you, because sometimes big places are hard unless you have referrals or other things, or maybe you just get lucky, because sometimes it can be just a luck thing. The process for internships is, I think it's like the same across the board in terms of like behavioral and just knowledge checking, but tech ones have a certain component that if you have to interact with, you kind of need to know about, which is coding interviews. Coding interviews are very interesting experiences. They're essentially, you're given a problem and you have a person, and you and that person have a web browser open, you see the same problem, and you're going to code live in front of them. And the goal of the process is not to go to the solution of the problem, because sometimes if you do enough of these, you might just want to go to the solution. The goal is to explain the whole thought process. And to give you an idea of what a problem could look like, it would be like, write code to reverse the elements in this array, so that in this, basically this list, I want, instead of it to be 1 2 3 4 5 6, it goes the back reverse. What I could do in coding, for example, is the simplest solution would be I make a new list and I just add each of the numbers from back to front to this new list. But then this is where you need to know engineering things, but that's not efficient, because now I have to use double the memory. So what if I instead just swap the 5 and the 1, and then the 2 and the 4, and then boom, I am done. I didn't have to use any extra memory to do it. So that's kind of like a very basic like engineering problem of just like realizing you should reverse it by actually swapping the like front and the back and slowly going inwards is the more efficient solution. And then another problem, removing duplicates. So you have this list and you want to remove all the duplicates. What I mean by that is like, so that if there are multiple ones, it's only the first one counts. And this one, if you know that there are data structures, there's a data structure called a set, like it works in mathematics. You can just put that into a set and then you'll get your result directly. So this is kind of like partially engineering, partially using math. These problems can get a lot more complicated, but they usually are solvable within 10, 15 minutes because you only have like 40 like minutes to do an interview. And so they're never going to be hard and complicated, but you do need to think about them. Best places to practice these problems, there's websites like LeetCode where they have hundreds of problems. And the goal is just kind of like go through them and try to like challenge yourself. So that's what you would kind of do if you were ever in a situation for a coding interview. Another fun tangent, because sometimes these jobs have these requirements that say you need to have a master's or a PhD. And so what do you do? Because you kind of want to, you probably need to stay in school for longer because sometimes, you know, we can't just do the route of bachelor's degree job. Because some, you know, we would like this because, you know, student debt goes down. Because yeah, you have a job, your job experience goes up. The downside of this approach is just you might get not all the opportunities and it might be hard to hit that entry data science position. And just a side tangent, for tech work at all, like student debt's always worth it for tech work. Like I have like 170K of student debt and that's fine because I make enough that that's not a problem at all, to put it in perspective. And so probably the next like typical route will be you go from bachelor's to master's to then a job. And there's some pros and cons. One, you probably gonna need to take on now the debt of the master's, which you can, I don't know, get a better loan from the government. It's also add on the 1 to 2 years more interest that are accruing on your bachelor's degree. Maybe you can get like a TA thing to like waive the tuition, blah, blah, blah. There's a lot of things that with that. But sort of the kind of potential things that you might get lost in that process would be if you could go to a job, you're missing out like on potential raises, already having 1 to 2 years of like income, knowing whether or not you really wanted to or need to do the masters, or just like living life. Because sometimes people just get into a job and they're just like, you know what? I don't need any more school. I'm done. That's what I feel like right now. But I'm trying to get into try to go do a master's also. Benefits, you definitely will get more pay. This is masters are always consideration and they always bump your pay up a little bit for it. Better job opportunities because now those positions that you couldn't get now are opening up finally. And even better, there are now internship opportunities that are only for grad students that you can now actually go after. So that's a benefit of it. But that's not the only route. You can do other routes. So for example, you just get into a job, it's okay. You then go to masters. Convenience thing, you have some job experience, you probably have more motivation to do a master's than just like, I need to do this master's because there's probably a job. Now it's like, I'm in this job, I want something more, I need the experience. You have better motivation, more job experience, more financially stable. It's a better time potentially. Another alternative is you can do them, you know, find an online master's program, and do the job at the same time. It's like the hybrid approach, except the only downside is you will have no life for about 1 to 2, 3 years. That's the it's you know, it's the caveat because now you have to spend your day working and then your night studying. It's not a fun cycle, and especially if it go for it being like over about a year or two, it's not a best cycle, but you'll get it done and you'll get kind of the both wins of job experience and getting that master's degree. What about PhD? Because sometimes there are some special jobs like researcher positions or any data position that you can ever want. It's unlocked if you have a PhD. Problem with that, your debt's compounding. If you have any student debt, it's compounding over 4 or 5 years. at that point for 5 years, you could easily be at a senior level position. So you could already be making a lot more money and you could have a lot more say in things. So that's kind of the like downside. You're making a very, very big trade-off. The benefit is pretty much all the data and analytics jobs you ever want, they're all open, because straight up, like any position that wants an analyst or like data scientist or machine learning engineer, like PhD is like the instant, like you have the highest chance out of anybody to get it. Though pay is a little bit interesting, because if you're going into a tech company, then yeah, I think pay might be questionable, because yeah, you probably will still get paid more for a PhD, but I don't know if it offsets quite what you kind of missed over time, unless you maybe rise up. So maybe you go in the position and then in a few years you go up into a more management position, and then it starts to get more justified because now you have like a greater reach. Do you really want to do this? PhD is not for everybody. There's alternative routes. You can go to masters. You can get the masters and say, okay, I don't want to do the whole PhD part. I'll just like take the masters and run. You can also just do the PhD later. Nothing stops you later, and it'll probably be better. And I'm just going to quickly go through. This is my last little thing. What advice I wish I knew before I went to school? Location kind of does matter. I learned this the nice way of being in Pittsburgh and not realizing that this was a major a hidden tech city. So it kind of does have an effect, but it's not always like the most important thing, but it does have its benefits. But definitely knowing people matters, like going to conferences, talking to people, making small interactions, and then maybe on LinkedIn at some point just saying, hey, I remember you from this thing. Do you mind if I ask for a referral? Like that could be your way of actually getting into the role you want. If anything, maximize experience. After my first internship, my whole goal was to always be doing something. So that's why I ended up doing like 5-6 internships and 2 research positions, because I just kept like trying to experience as many different things as I could put my hands on. And the key thing of being a person in the analytics space is that just refine your toolbox, because I think in most cases your toolbox is the same, just the data will be different. And just like to explain this, like I basically, for me, the engineering tools are always the same. Every company, it's like I go from healthcare data to autonomous car data to cyber intelligence data. Like the tools are the same, just the data is different pretty much all the time. But that's all I have to say. Any questions?
Can we get a round of applause? I thought that was fantastic. Thank you, Alex.
Alex.
Cool. I think we're going to hand it over to Amish, and he'll do like a Q&A. We only have a few participants here, so we should be able to elaborate on any questions people have.
Yeah, let's take 5 to 10 minutes for any Q&A. If you guys have any questions, feel free to unmute your mic and speak up, or drop it in the chat. Good. I'll start us off. Alex, I wanted to know, what is the difference between like data mining, data analysis, being a data scientist? What are all the, how do these terms connect?
Got it. So I think the best way to explain, okay, there's a slide. How I do transitions, I make individual slides. So there's like 130 slides. So I'm trying to find the one that described it perfectly. It was this one. So the difference between those is dependent upon where it is kind of in this cycle. So like all these data things have a certain cycle where it's like collecting data, cleaning the data, analysis, results. And so like data mining is part of kind of like shuffling and getting things in order. So like what I do at my job, what I mean by data mining, is I'm taking existing data and I'm just altering it in a certain way to give more useful things. And so one of those would be like saying, is it daytime or is it nighttime? Because that's nowhere in the data. Like just easy, just like, I want to know when it's daytime, when it's raining outside, I want to find those points when the vehicle is at. So that's kind of things like I'm basically kind of data mining is kind of like getting those higher level features up and ready so that like the next step, a data scientist can look at that, be like, I want to find all these things and then do the analysis. So that's kind of like, data engineer, data analyst, or data science analyst. The terms are very confusing. It's a very wishy-washy field.
No, I appreciate the diagram. That's definitely helpful. Any questions from anyone else?
Hi, I have a question on the skill set for the just basically like the baseline or the bottom of the pyramid. Basically, like how do you, like for instance, I was learning linear algebra, and after learning linear algebra, how do you basically retain that while trying to pick up more Python skills and like for instance like data structures, and how do you like memorize that so you can combine both of them at the same time? Is that just through experience probably?
It is kind of through experience, because like for me, it's like I learned linear algebra and then I didn't have to use it for 2 years. And then eventually I got hit with deep learning and then I had to relearn it all again. It is kind of like you do revisit it, but eventually it starts to, if you start working in certain parts, it will come up over and over again. But I mean, probably besides all the other skills I mentioned, the most key skill is always to be learning. So this is like, it's just a natural function of how things work.
Thank you.
I think we have one over here, if that's okay, Mish.
Yeah, go for it. I can't see you. I don't know what happened to your camera.
Right. There's another person here. Do you want to introduce yourself?
Hi, I'm Shola. I just graduated from FAU with a major in computer engineering. Yeah, so basically my question is, when it comes to learning these new skills, whenever you were learning machine learning or data science or anything like that, how did you do it? Was it all through school, or did you use online resources? If so, which ones? So on and so forth.
Yeah, so for learning those skills, it's a combination. I think, but primarily I learned it from school. Like there is, university still has a function. That's why I say like the degree is still a baseline. Like it does justify that I probably know something. So some of it just because like, yeah, I took classes on statistical learning and data science and machine learning and deep learning. Some of it is I learn outside, or like I pay online resources. So one of them would have been at some point I paid Udacity to take a course on reinforcement learning, because I was like, ooh, that sounds cool. I'm gonna do that and have fun with it. I mean, the course costs like $1,000, but so like definitely find something cheaper, like on Udemy or something like that. Don't overpay, but I was like, I can afford it. It's like, it's okay. And I still got a lot out of it. Those are, so yeah, online in college, and sometimes just I wouldn't, because I can't say personal projects per se, because most of the time I learn all these things in class and then I apply it to personal projects where it gets reinforced. That would be like the best. Yeah. So yeah, in class and online.
Makes sense.
Thank you, Alex. Anyone else?
All right. If not, let's give our speaker a round of applause one more time. Thank you so much, Alex.
We'll do that.
It's fun being here. This is great.
The pleasure to have you. I'll stop the recording. It will be available on our YouTube Cyan page soon.
Fantastic.